Hello, my name is Stephen Powers. This is my presentation on the impact that AI has had on the utility industry. This is for course Management 9390, Managing Business Analytics. This is actually a topic that I know a decent amount about. The company that I work for, IPS Integrated Power Services, shown in the bottom left corner of this slide, is one that I actively work for as an operations manager. We do industrial equipment repair for mines, power plants, heavy industry, and in recent history have been doing a lot of vibration upgrades, temperature sensor upgrades, remote monitoring upgrades for AI condition monitoring of equipment at power plants, specifically nuclear power plants. Shown in this slide, top left-hand corner, is a heater drain motor from a nuclear power plant in the Northeast, as well as in the top right corner is what's called a circulating water pump for a nuclear power plant in Georgia. These two pieces of equipment were pulled and maintained on a standard basis using the equipment that's attached to them, specifically Bentley Nevada sensors and SKF sensors to provide condition monitoring of the equipment and smart analyzation of when the equipment should be pulled. Overall, the end goal is to create a more efficient plant with less downtime and more uptime when needed. A couple of the industries that we work for, FPL, Shell, and NextEra, have all been champions of this new electronic condition monitoring and data usage to maintain their equipment. AI enables predictive maintenance, which includes on-time PMs, reduction in frontline staffing, and strategic equipment replacement, as well as providing load forecasting, which allows you to know when your peak times are going to be for loading and you ensure you have proper resources, as well as smart grid management. As we all know from our core studies so far, strong data practices are now a competitive necessity. These three, for me, they're customers, but these three providers are leading in the industry of AI and using it to maintain their equipment. Some key challenges in AI's role in them. As industries grow and develop, outdated systems are prevalent, there's aging equipment everywhere, and inconsistent renewables. AI solutions to this are predictive maintenance, smart monitoring with technology like SKF and Bentley Nevada sensors, as well as energy demand forecasting during non-seasonal weather changes. From our studies so far, we know that AI must be embraced at both leadership and frontline levels for its success and for continued usage. Following the STEP framework analysis, the first step in the STEP framework analysis is social. In this case, it's improved energy access and reduced outages. Social has a big pro to it in that it's always, in this case, the grid will always have enough power to support the load at the exact time that is needed. Con, if the data is incorrect and out of season weather hits, say like an ice storm in Texas, the system can fail. Technological use of AutoML and MLOps, as well as edge computing, provide that big data analysis and computation to be able to efficiently plan and run outages as well as predictive maintenance. Economics, cost savings, job creation, and efficiency boosts. Environmental, emissions reduction, and pollution monitoring. This has been a big push as of late, probably for the past 10, 15 years, to make power plants and general industry more efficient and less carbon footprint. Political, green energy incentives, and public-private support. As we all know, this has gotten a huge focus here lately, and NextEra and FPL have been big champions of that lately, turning a lot of coal power plants into combined cycle to improve efficiency as well as their carbon footprint. Regulation and ethics. Some of these include laws like the U.S. Energy Policy Act, EU Clean Energy Package, and GDPR. Companies must act ethically while dealing with data and not compromise privacy, as shown in the GDPR. Energy Acts Act provides loan guarantees for entities that develop or use innovative technologies that avoid the byproduction of greenhouse gases. Another provision of the Act increased the amount of biofuel that must be mixed with gasoline sold in the United States. Ethical concerns, fairness and bias in AI. You can't use your data to, you know, alienate a specific work group or target any particular person. Job displacement. One of the key focuses that we've had here at IPS is making sure that AI and big data does not translate into a reduction in force, instead an increase of training to be able to retrain employees who are familiar in our industry, but not necessarily familiar in AI. And last being transparency and accountability. In the global scope, adaptability needed for different regions and infrastructures. Not every system is going to be the exact same, and it must be custom tailored to the industry that you're working in. Overall, companies are using AI and big data to help run their plants more effectively and more efficiently, reducing waste and reducing the amount of time people have to actually spend going and taking data, doing machine evaluations, and making sure that rather than on a hunch of we'll need X amount of power, we're using data to be able to forecast how much power we will need. Shown here is a power plant in Florida that's being converted now from coal to combined cycle, as well as going through a big condition monitoring upgrade to be able to reduce the number of frontline employees that are needed at the plant at any given time, as well as make it more efficient and provide cleaner power. Here are the references that I've used throughout the PowerPoint and the associated paper